When you look at the sky at night, have you ever thought about how far a distant planet is from where we are on Earth? There are several methods for observing celestial bodies, especially to determine their distance and magnitude. However, what is commonly used is the parallax method. Our Earth revolves around the Sun for 1 year. Suppose we observe a celestial body A in January and July. Then we compare the position of celestial body A relative to distant stars by drawing the following observation. By measuring the parallax angle P, we can actually calculate the distance D. From the figure, it can be seen that R equals to D multiplied by P with D, distance from Earth to celestial body, P, angle in radians, and R, Earth and Sun's orbital radius. To understand the unit of the angle radian, consider the following explanation. 1 radian is the angle of a circle when the length of the chord is equal to the length of the radius. In other words, the radian is a kind of creative way of determining the relationship between angle of a circle and its distance in a circular motion. Using the comparison, we get distance divided by the formula of a circular circumference equals to theta divided by 360 degrees. Since in radians, the distance measured must be equal to the radius length, which as well means R divided by 2πr equals to theta divided by 360 degrees. Therefore, from the formula, we get that 1 radian equals to 57.3 degrees. That makes 1 degree equals to 0.0175 radians. Equally, that means 1 arc minute equals to 2.91 times 10 raised to the power of minus 4 radians. With 1 arc second equals to 4.85 times 10 raised to the power of minus 6 radians. Here's another example. If the parallax angle of a celestial body is 0.5 degrees, how far is the celestial body from the Earth? Since 1 degree equals to 0.0175 radians, that makes 0.5 degree equal to 0.0087 radians. From the picture, we get D equals to 1 AU divided by 0.0087 equals to 114.6 times 150 million kilometer equals to 1.72 times 10 raised to the power of 13 meter. Now we are going to measure the volume of a planet. To measure the volume of a planet, we need to measure the diameter of the planet first. The trick is to measure the angular diameter of the planet A, for example. The angular diameter here must be measured in radians, just like the figure. Example is this figure, with D signifies planet diameter, A, the angular diameter of the planet as seen from the Earth, and R, the Earth's distance from the planet. From the figure, we can use the comparison. D divided by 2 times P times R equals to A divided by 2 times P, with D equals to A times R. To measure the diameter of a superior planet, people observe the planet when it is in a state of opposition. Astronomical opposition means that a planet is located on the opposite side of the Earth from the Sun. From our perspective, it means a planet at opposition is precisely 180 degrees from the Sun in the sky. So when the sun sets in the west, a planet appears in the east, as it is depicted in this picture. In times of oppositions, the planet will appear larger than usual. Here's another example problem and the last one to hone your understanding. Person observes the planet Mars in a state of opposition. Mars is in opposition every 780 days. Because of its elliptical orbit, once every 60 years, Mars will reach its closest distance, which is about 55 million kilometers. At the time, the angular diameter of Mars was about 25.5 arcseconds. The question, what is the diameter of Mars? Also, calculate the volume of Mars. From an example before, we get that 1 second degree equals to 4.85 times 10 raised to the power of -6 radians. So 25.5 second degrees equals to 1.24 times 10 raised to the power of -4 radians. By using the triangle on the side, we get D equals to R times A equals to 55 million kilometers times 1.24 times 10 raised to the power of -4 equals to 6820 kilometers. Then we are looking for its radius. The radius is the half of its diameter, so its diameter divided by 2 equals to 3410 kilometers. Subsequently, as we round up the number after the nearest 100, it will be 3400 kilometers. Whereas the volume of Mars is calculated by the spherical formula of 4/3 times 3.14 times 3400 kilometers raised to the power of 3, which equals to 1660 times 10 raised to the power of 11 kilometer cube. And that's all, guys. I hope my explanation was easy to understand. See you again in the next video, and thanks for watching.